Hello and welcome. This is a collaboration between MySecretMathTutor and Mario's Math Tutoring. In this video, you'll see us go through a final exam review that is appropriate for an Algebra 1 class. So there's going to be lots of different problems, but if you're in Algebra 1 or you're thinking about it, you'll see lots of different problems that you would see in that type of class. All right? Also in this video, I'll be taking care of the even problems, and Mario will be taking care of the odd ones.
Okay, number 21, we're talking about factoring. And when it says factor completely, that means that you might have to factor and then factor a little bit more and factor a little bit more. You want to keep factoring as much as you possibly can. Now, the first step in factoring is always the greatest common factor. So you always want to see if there's something you can divide out of all the terms. Remember, the terms are separated by minus or plus. So when I look at these two groups, I say, well, what can I divide them both by? It looks like we can divide these both by 16. It looks like this one has two A's, this one has one A, so we can divide them both by one A. This has one B, this has like three B's, so we can divide them both by one B. So you're looking for the most that you can divide out of both terms, that's in common. So now if I divide, you can see I have 3. A squared divided by A is just going to be A. Here the B's cancel. Over here, 16 divided by 16 is just 1. The A's cancel, and B cubed divided by B, remember when you divide, you subtract. So that's going to be B squared. But you see this 16AB we divided both the terms by? You want to put that in front of the parentheses. So in this case, that's as far as we can factor, and it was just factoring out that greatest common factor, seeing what we could divide out of both terms. But you want to look to see if you can factor further after you do that. For letter B, we've got 36y squared minus 9. Now again, remember the first step is always the greatest common factor. So here it looks like we can divide these both by 9. So if we factor out that 9, we have 4y squared minus 1. Now what might jump out at you at this point is we have a difference of 2 squares. Remember, a difference of 2 squares is like this: a squared minus b squared. It factors to a plus b times a minus b. So that's the sum and difference pattern. So notice that this is a perfect square because 2y times itself, and 1's a perfect square because 1 times itself. One of these we're adding, one of these we're subtracting, and I just bring down that 9 in front. So this is, a couple steps on this one. First, greatest common factor, then a difference of 2 squares. You might want to add this to your formula sheet for a difference of 2 squares. Now for letter C, notice how we have 1, 2, 3, 4 terms. When you have 4 terms, you want to see if you can factor by grouping. But again, the first step is always the greatest common factor. In this case, there isn't a greatest common factor, but because there's 4 terms, what I'm going to do is I'm going to group these first 2 terms together. I'm going to group these last 2 terms together. Notice I captured that minus sign, and these are really like added together, all these terms. So then what you do is you say, well, what can I divide out of both of these? Well, it looks like I can divide out a y squared. So if I divide out that y squared, I have 3y plus 2. Here I can factor out a negative 1. So that's going to give us 3y plus 2. Now notice how what's in parentheses is the exact same, 3y plus 2. If we factor out the 3y plus 2, from this first group, we're going to be left with y squared. If we factor out the 3y plus 2 out of this group, we're going to be left with minus 1. But notice that this y squared minus 1 is a difference of 2 squares, just like we talked about here. And you can factor this further as y plus 1, y minus 1, and then I'm just going to bring down the 3y plus 2, and that's your final fully factored form. So factoring by grouping when you have 4 terms, if possible. Letter D, we've got f squared minus 7f plus 12. Okay, so now for this one, it's a trinomial, 3 terms. The leading coefficient's 1. These ones are very easy to factor because all you have to say is what 2 numbers multiply to 12 but add to negative 7. So what 2 numbers multiply to the last number but add to the middle coefficient? That's going to be negative 4 and negative 3. Of course, f times f is going to give you the f squared, and you can double check. See, negative 4f, negative 3f is the middle, negative 7f. So that one was pretty straightforward. Letter E, though, a little bit more challenging. We have a trinomial where the leading coefficient is not 1. Now, there's a lot of different techniques. There's the trial and error method. There's the splitting the middle term and factoring by grouping. But a lot of students like what they call the box method. In the box method, you multiply the A value times the C value. So this coefficient times this constant. So you say to yourself, what 2 numbers multiply to negative 30 See, 3 times negative 10 is negative 30. But they have to add to this middle coefficient, which you can see is negative 1. So that would be negative 6 and positive 5. See, it has to be the same two numbers. They multiply negative 30, but they also add a negative 1. So now what we do is we make a box like so. And we put the first term 3x squared here. We put the last number constant, negative 10, over here. But you see the negative 6 and the 5? We're going to split up this negative 1x into negative 6x and positive 5x, because see how those add up to negative 1x. Now, it doesn't matter where you put these. Either one is fine, but you want to have the 3x squared here and the negative 10 here. Now what I like to do is look at the rows, and I say to myself, what can I factor out of both of these terms in this top row? Well, I can factor out a 3x. If I do that, I'm going to get x. If I divide this by 3x, I get negative 2. Now here, what can I factor out of both of these? I can factor out a 5. And you can see if I factor out a 5, I'll be left with x. If I factor out a 5 here, I get a negative 2, or divide by 5. So these are our two factors. It's going to be x minus 2, see right here, and 3x plus 5. And the nice thing about factoring is you can always check your work. If you FOIL it out, you'll get back the original trinomial.
For these problems, we can use what is known as the zero factor property. That essentially says that if you have two pieces that are being multiplied together to equal 0, then you know that either a is equal to 0 or b is equal to 0. So we're really seeing that here with our polynomials. Either this piece is equal to 0 or this piece is equal to 0. And it really cuts down the solving process by quite a bit. Instead of having to solve a fairly long or complicated looking polynomial, instead I have these two much simpler ones. All right, so let's go ahead and solve each one of these individually. So if I move the 1 to the other side, and then I can go ahead and divide by 2, I'll get a solution of y equals 1/2. Doing the same on the other side here, let's see, I got a 5y, let's go ahead and subtract a 3, and then divide by 5. So I have two different solutions, that y could equal a 1/2, or that y could equal a negative 3/5. Now we want to think of that process again with the second one, but notice how it's not into pieces that are multiplied, though if I do some factoring, we can get it in that form. Both these terms have a 2 in common, and they both have a d in common. So let's go ahead and take that out. Let's see, let's just double check our factoring. So 2d times d would be equal to 2d squared, and 2d times a negative 9 would be a negative 18d. So everything's on the up and up, our factoring is correct, and now I have my two pieces, so I can say 2d is equal to 0, or d minus 9 is equal to 0, and then solve each of these individually. Dividing by 2 over here, we have 0, and adding 9 to this one, we have d equals 9. So here are our two solutions for that one. D is equal to 0, or D is equal to 9.
Okay, number 23, it says identify the vertex, the axis of symmetry, the y-intercept, and then graph. We've got two problems here. For letter A, y equals negative 2x squared plus 1. What you'll notice about this one is, see how it's in the form y equals ax squared plus c? There's no b value. So what that tells you is that this graph is just being either stretched or compressed or reflected if it's negative, and then the c is shifting it up and down. Okay, so if c is positive, it goes up. If c is negative, it goes down. So you can see with this one, the 2 is stretching the parabola. Okay, it's reflecting it over the x-axis, which means it opens down, and then the 1 is going to shift it up 1. So what we can see here is if we graph this, because it's not shifting left or right, there's not a b value, it's just going up or down, it's going to go up 1. Okay, so there's our vertex, and then the negative is going to be opening it down, and the 2 is going to be stretching it, which is going to make the graph narrower. Now what you can do if you want is you can make a table, and you can pick some values on either side of this vertex. So we said the vertex is at 0, 1. The axis of symmetry will also go through that vertex, so that axis of symmetry, meaning it's going to be the same on both sides, is going to be x equals 0. Remember, x equals lines are vertical lines. But let's go ahead and plot some points. So let's say, for example, if I put 1 in, 1 squared is 1, times negative 2 is negative 2, plus 1 is negative 1. So that means you're going to be right here at 1, negative 1, and I can reflect that over this line of symmetry right here. Let's pick another point. How about 2? If we put 2 in, we get 2 squared is 4, times negative 2 is negative 8, plus 1 is negative 7. So this is going to be at 2, negative 7 down here. And again, I can reflect that over the axis of symmetry. And you've got your graph. So y-intercept here was right at 0, 1. Okay, for letter B, a little bit more challenging. This one is in the form y equals ax squared plus bx plus c. So this one, what we want to do is we want to find that vertex, that point where the graph is bending. And there's a little formula that you might want to add to your formula sheet. It's x equals negative b over 2a. So in this case, the opposite of b would be the opposite of negative 4, which is going to be positive 4, over 2 times a, which in this case you can see a is 1. So 4 divided by 2 is equal to 2. Now that's going to be our x-coordinate of our vertex. If we take the 2 and we put it back in for x, we can get our y-coordinate of our vertex. So let's go ahead and do that. That's 2 squared minus 4 times 2 plus 5. That's 4 minus 8 plus 5, which is negative 4 plus 5, which is 1. So now if we draw a graph, you can see that this is going to be at 2, 1. That's our vertex. Okay. Our axis of symmetry goes right through that vertex. So that's going to be the line x equals 2. It's always going to be the same as the x-coordinate of the vertex. And then let's go ahead and find the y-intercept. So where it crosses the y-axis here is where x equals 0. So if I put 0 in for x, you can see that y is equal to 5. 2, 3, 4, 5. And if I reflect that over that axis of symmetry, that's going to be, see how I'm 2 to the left of the axis of symmetry? If I go 2 to the right, I'm also going to be at a height of 5. And you can draw your graph. Now, if you want to get more points, you could plug in, say, for example, 1 or 3. So let's go ahead and put 1 in. That's 1 minus 4, which is negative 3, plus 5 is 2. So this is going to be right here, and I'm going to reflect it. And now we have a good sketch of our parabola.
For this one, we want to describe the transformations happening in our various different functions by comparing them to the parent function of x squared. For these, let's see what's going on. Starting off with the first one. So we can see we have that x squared piece, and then the 3 and the minus 1 are really outside of that. So first, I'm going to take a look at this negative 3. Since it's being multiplied and it's on the outside, I would consider this a vertical stretch by 3. So what that's doing is it's making the parabola look a lot skinnier and taller than what we'd normally have. This minus 1 is also on the outside, so it's going to move it up or down. We could say that this is a shift or a vertical shift by 1. Let's see, what's else? How else can we say this? Let's just say that it shifts down by 1. All right, on to the next one. This one actually has what I would think 3 different transformations, so let's take care of them carefully one at a time. The first little transformation that I really want to point out is this negative sign. All right, see that negative on the negative 1/4? If you only look at just that negative sign, this is a reflection. So we will say that it reflects over x-axis. Now the 1/4 has a very similar behavior to what the 3 did before. It's going to do a stretching or shrinking in the vertical direction. So I will call this a vertical shrink, and the reason why I'm calling it a shrink rather than a stretch is because it is a number between 0 and 1. So those kind of like shrink it in the vertical direction. How much does it shrink it by? You could say it shrinks it by a factor of 4, since it is a 1/4. And that'll work out just fine. So that's for the 1/4 part. All right, let's see. We got another transformation. This one is also on the outside. It comes from that +2. Since it's a plus, it will shift it, but it will shift it up by 2. All right, and one more to go. This one is a little bit different. Notice how the +2 is actually right next to the x. This is an inside transformation. And these tend to work the opposite of what our intuition says they should do, but they work just fine otherwise. So this will go ahead and shift left by 2. So we'll go ahead and point that out. And our +3 on the end, very similar to that +2 and the -1 we had earlier. This will shift up by 3. And those are all of our transformations for these. Only one of them had an inside transformation, and remember you can see the inside transformations because they'll be right next to the x piece.
Okay, number 25, we're going to solve these quadratic equations by completing the square. So what you want to do is you want to first get this constant on the other side of the equation. So I'm going to add 20 to both sides. So that's going to give us 20. And here we have x squared minus 8x. Now what we want to do is you want this leading coefficient to be 1. If it's not 1, you can divide everything by that leading coefficient. It's going to make it easier to complete the square. But the next step is you want to take this b value, this number that's in front of the x, you want to divide it by 2 and square it. So what I'm going to do is I'm going to take half of -8, which is -4, then I'm going to square that, which is 16, and you want to add the 16 to both sides of the equation to keep it balanced. Okay, now what you can see is we have a perfect square, okay, meaning we can factor this, and it's going to factor to, it'll always be half of this middle coefficient. So if this was +8, this would be +4. If it's -8, it's going to be -4, the quantity squared. Now, if you want to double check your work, if you take x minus 4 times x minus 4 and you FOIL that out, you'll get back this trinomial. So now we've completed the square, but now we want to get to the solving part, and we're going to do that by taking the square root of both sides, because the square and the square root, those cancel. When you take the square root of both sides, you get two answers, plus or minus 6. And here we have x minus 4. Now, a lot of students, what they'll do is just break this up into two equations. X minus 4 equals +6, x minus 4 equals -6. That's an easy way to do it, just to make sure you don't make any mistakes. If you add 4 to both sides, you're going to get x equals 10. If you add 4 here to both sides, you're going to get x equals -2. So those are your two answers, 10 or -2. For part B, though, see how we have that leading coefficient? So this one's a little bit more challenging. I'm going to get this constant to the other side of the equation just to get it like out of the way. So that's going to give you 27, okay? And here we have 3x squared minus 12x equals 27. I'm going to divide everything by 3, okay, both sides of the equation to keep the equation balanced. So here we have x squared minus 4x. And then now we just have to get to the completing the square. So we say half of -4 is -2. -2 squared is 4. If I add 4 to the left side, I have to add 4 to the right side to keep it balanced. This is equal to 13. And now we can factor this. And remember that technique, it's always half of that middle coefficient. So it's going to be -2. So x minus 2 squared equals 13. If it was +4, this would be +2. Now we just have to take the square root of both sides. When we do that, we get two answers, plus or minus. The square and the square root cancel. And we can split it up into two equations. X minus 2 equals positive square root of 13, and x minus 2 equals negative square root of 13. Now what I'm going to do is I'm just going to add 2 to both sides. So x equals 2 plus square root of 13. Add 2 to both sides. X equals 2 minus square root of 13. And those are exact answers. If you want to put that into your calculator, you can get a decimal approximation.
All right, let's go ahead and find some square roots. In a square root, you're trying to think of two numbers that would multiply and give you the given number. So this, we're really trying to figure out what is the square root of something like 169. Now, when you're doing square roots, it's probably a good idea to think of numbers and squaring them. And especially if they're big, sometimes you can use smaller numbers to get some good intuition. So for example, I might take a guess and say, well, is it 4 squared? Well, 4 times 4 is 16, so that is going to be way too small. Jumping up a bit bigger, I could say, well, maybe it's 10 squared. That's 100, so at least we're getting in the ballpark. 12 squared is 144, so we're really close. And finally, when we get to 13 squared, there's our 169. So I know that the square root of 169 is 13. Or again, another way of looking at this is since 13 times 13 is equal to 169, then the square root of 169 is equal to 13. Now for the next problem, sometimes you can break down that number into smaller square numbers. So when I first looked at the square root of 36, what really came to mind was that 36 was the same as 4 times 9. And the reason why I'm breaking it into these two smaller numbers is because I know their square roots a little bit easier by heart. So the square root of 4 is just 2, and the square root of 9 is 3. So then I can take their individual results, put them back together, and I get an answer like 6. So in the grand scheme of things, the square root of 36 is equal to 6.
Okay, number 27, we're talking about simplifying radicals and radical expressions. We're assuming that all the variables in these problems are positive. For letter A, we want to simplify the square root of 50. There's a couple different ways to do this. One way is to try to divide out perfect squares like 4, 9, 16, 25, etc. So here we can see that 50 is really like 25 times 2. The square root of 25 is 5, and we're left with square root of 2. We can't divide out a perfect square out of 2, so that's as far as we can go. The other way to do this, if you want, some students like to make a prime factorization tree. Okay, you break down the number into the prime numbers, and if you're taking the square root, you look for 2 of the same number. For every group of 2, you just end up with 1 of that number. See, this is like 25, square root of 25 is 5, you have the 2 left over. Now say there was a 2 and a 3 left over, you'd multiply those together, it would be 6, So let's go to letter B now. So this one, we've got square root of 49, a to the 8th, b to the 4th, c to the 2nd. So square root of 49 we know is 7. What times itself is a to the 8th? Well, that's going to be a to the 4th. What times itself is b to the 4th? That's b squared times b squared. And what times itself is c squared? That's going to be c. The other way to look at this problem is like a to the 8th is really like 1, 2, 3, 4, 5, 6, 7, 8 eighths, right? You could break it all down. And then you look for groups of 2. 1, 2, 3, 4 groups of 2. So this is a times a times a times a, which is a to the 4th. So you can expand it out like that and look for those groups. For letter C, we've got negative 3 times this square root. Now, I'm going to do that method I talked about breaking it up. So 27 I know is 3 times 3 times 3. X to the 4th is 1, 2, 3, 4. And y to the 7th is 1, 2, 3, 4, 5, 6, 7. We're looking for groups of 2 since we're taking the square root. So there's a group of 2, group of 2, group of 2, group of 2. Okay, like that. So we have 3. Okay. We have x times x, which is x squared, y times y times y, which is y cubed, and what's left over is a 3 and a y. But you see this negative 3 here? This negative 3 is right next to the square root. That means they're multiplied together. So if we simplify this further, we have negative 9 x squared y cubed square root of 3y. Now another way of looking at this is, especially with the variables to a power, what I like to do is say, how many times does 2 go into 4? It goes in 2 times with none left over. How many times does 2 go into 7? 3 times with 1 left over. So that's an easier way of doing it instead of like expanding it all out. Okay, for letter D now, we have a fraction, and notice there's a square root in the denominator. This is considered improper. When it's a binomial like this, what you want to do is you want to multiply by its conjugate. And what is the conjugate? Well, if this was 1 minus square root of 2, I'd multiply by 1 plus square root of 2. If it's plus, this is minus. So you just change that sign that's in between the two terms. That's the conjugate. But whatever you do to the denominator, you want to do to the numerator. Now all we have to do is do a little bit of multiplication. So if we distribute the negative 3, we get negative 3 plus 3 square root of 2, because a negative times a negative is a positive. Here, though, we have to distribute twice. So we have 1 times 1, which is 1. 1 times negative root 2 is negative root 2. Positive root 2 times 1 is positive square root of 2. And negative square root 2 times positive square root of 2 is negative square root of 4. Okay, but the square root of 4 is 2, so that's just going to be negative 2, because a positive times a negative is a negative. Notice that these guys cancel. This is what we call a sum and difference pattern. So that inner product and the outer product are canceling. You just get the first and the last. 1 minus 2 is negative 1. So if we divide the numerator by negative 1, we get positive 3 minus 3 root 2. That's your final answer. For letter E, we're multiplying these two quantities together. Now, what you want to do when you're multiplying is you want to think about multiplying like terms. So I'm going to multiply the parts that are on the outside. 2 times negative 3 is negative 6. And I'm going to multiply what's on the inside. 5 times 6, which is 30. 30 is just 2 times 3 times 5. So we don't have a group of 2 that we can factor out a perfect square. So this is as far as we can go with that one. Letter F, we have the square root of a fraction. With these ones, what I like to do is split it up into square root of the numerator over square root of the denominator. Square root of 25 is 5. Square root of 8 is really like square root of 4 times square root of 2. Square root of 4 is 2, so that's 2 root 2. But again, we don't want that radical in the denominator, kind of like this one, but this is a monomial. I want to get rid of that square root of 2, so I'm just going to multiply the top and bottom by square root of 2. Square root of 2 times square root of 2 is just 2. Times, see, this is square root of 4, but square root of 4 is 2 times 2 is 4. and then we just have 5 square root of 2. Don't make the mistake of making the square root of 10. When you multiply a number times the square root, they're different types of terms. You just put them next to each other. And then if you could reduce these further, I would, but that's as far as we can go on that one. For letter G now, square root of 32, we can simplify this into square root of 16 times square root of 2. So that's 4 square root of 2. 18 is really like square root of 9 times square root of 2. So that's 3, but then times that 3 is going to give you 9 square root of 2. Okay, I just brought that down, that minus sign. And then 4 square roots of 2 minus 9 square roots of 2. Since these are both the same type of term, like the same type of 4 of these groups minus 9 of the same type of group, right? That's going to be negative 5 square root of 2. And you got it. Now, if this was 4 square root of 2 minus 9 square root of 3, we wouldn't be able to combine them because they're unlike terms.
All right, let's move on to solving some radical equations. To solve these, we can usually start off by isolating the radical and then squaring both sides to get rid of it. Okay, squaring on the left side here, this will give us a 2x minus 3. Squaring on the right, we have a 25. Okay, so that's looking pretty good, but now it's a nice linear equation, so we want to work on getting the x all by itself. We can do that by adding 3 to both sides, giving us a 28. Dividing by 2, I get a 14. Now, as a good idea with all radical equations, probably go ahead and test that back into the original to see if it really works. This is because in that squaring process, sometimes you can introduce what are known as extraneous roots. In other words, you might end up with solutions that don't work in the original. So I'm putting this back in the original, and we just want to see, does this really equal 5 or not? All right, so 2 times 14 is the 28. Still underneath the square root. 28 minus 3 is 25. And the square root of 25 is equal to 5, so yep, that's what we had before. So I know that x equals 4. I know that this is x equals 14 is a valid solution. All right, the second one has a couple of radical symbols in it, so it's going to be a little bit more complicated, but not too much more. We just want to pick one of these radicals and get it all by itself on one side of the equal sign. So I'm going to keep this over here, but I'm going to move the other one to the other side. Now, like before, we can square both sides to get rid of that x squared minus 3. So let's go ahead and square over here, and we'll go ahead and square on the right side. So that'll give us an x minus 3. That looks good. Here we want to think of foiling that out. So 9 minus a 3 square root of x minus a 3 square root of x. Negative square root of x squared will give us a positive x. That's just a reminder. Let's go ahead and mark that we foiled that. All right, we're not out of the woods yet. We still have one more square root, but there are a lot of other terms that we could go ahead and get rid of, or at least simplify, to make our lives a little bit easier. So for example, here I have an x on this side. I can subtract it from that side, and then both my x's are gone. Let's see, what else can we do? We can add 3 and combine those terms. So let's see, I've kind of moved everything from that side, so that's just a 0. Here's a 12, minus 3x squared, minus 3x squared, minus 6 square root of x. Okay, that's good. So now I can see that I only have a single square root over here, and we'll get it all by itself by moving it to the left over here. Now I can divide by 6 and take the square root. So let's see, divide by 6 would give me a 2. Squaring both sides now, let's see, what did that give us? 2 squared is a 4. So squared, squared. So x is equal to 4. All right, just like last time, we may have introduced some extraneous square roots. So let's quickly run back to the original and see if this is true or not. So I'm putting in the 4 for x. And we want to know, does this really equal 3 by the time the dust all settles? Square root of 4 is 2. 4 minus 3 is just a 1. So I'm dealing with 2 plus 1. Yes, that is really equal to 3. So I know that x equals 4 is a valid solution. So we'll go ahead and keep it.
Okay, number 29, you can see we have a right triangle here. We want to find out what x is. One way to do this is just to do the Pythagorean Theorem. You could say a squared plus b squared equals c squared. So that would be x squared plus 9 squared is 81 equals 15 squared, which is 225. Subtract 81 from both sides, and that's going to be 144, and then if you take the square root of both sides, you get x equals 12. Now, another method that you can use is, you see how 9 and 15 are both divisible by 3? So if I divide this by 3, I get 3. If I divide this by 3, I get 5. And if you can recognize these Pythagorean triples, 3, 4, 5 is a common Pythagorean triple. But you see how I multiplied 3 times 3 to get 9, 3 times 5 to get 15, 3 times 4 to get 12. You know, that's kind of a quicker way to do that. So 3, 4, 5 is a good one to memorize. Also 5, 12, 13 is a good one to memorize. 8, 15, 17 is another good one. And 7, 24, 25. So this is really good when you take the ACT, SAT, but good as you go on in math.
All right, more on to simplifying some rational expressions. With rational expressions, it's kind of tough to see if they simplify or not until we get them in their factored form. So let's go ahead and take these and begin factoring the top and bottom to see if there's any terms we might be able to cancel out. All right, starting with the top one here. Two numbers that will multiply to give me an x squared will be an x and x. Two numbers that will multiply to be 15, I could use 3 and 5. And in fact, that seems like a really good idea to do since the difference or the distance between them is 2, and that's what I'm seeing in the middle. Now, since I have a negative 2, I know the larger of these numbers must be negative. So we'll go ahead and make that negative and the other one positive. And now the top is factored. Moving on to the bottom, same as before, two numbers that will multiply to give me an x squared. Well, it's got to be an x and an x. And then two numbers that will multiply to be the 3, I'm thinking of 1 and 3. Now these can add to be 4, so if I make these both positive, then we're good to go there. All right, now that it's in a nice factored form, I can see that I have a common factor of x plus 3 in the top and in the bottom, so we can go ahead and get rid of those. This will just leave us with an x minus 5 in the top and an x plus 1 in the bottom. So now that one is simplified. All right, moving on to the next one. Not a whole lot to simplify here, except for this term in the bottom. That's an x plus 7 and an x minus 7. So we want to think of that instead. All right, let's see. What else can we simplify? Well, I got some numbers. I can cancel out some terms. But I think if I cancel out this x minus 7, that'll clean up things by quite a bit. We can also get rid of one of these x's, so we'll do that. Let's see what that would leave us with. There's a 3x, all divided by 9, x plus 7. All right, we've canceled a bunch out, but actually it looks like we can also reduce these numbers, so let's go ahead and do that. 3 goes into 9 3 times, so I'll end up with x divided by 3, x plus 7, and now we're simplified as much as possible. So we'll go ahead and leave it like that. All right, on the next one, let's do some factoring. Two numbers that will multiply to give me an x squared, got to be x and x. Two numbers that will multiply to be 40, well, I have lots of options for those. It could be 1, 40, 2, and 20. So maybe we'll come back to that. You know, I'll think on that for just a little bit. And let's go ahead and look at this second piece. Here I'm dividing by an x minus 5. And to better match some of my other problems, I want to think of this as a multiplication problem. So I want to multiply it by 1 divided by x x minus 5. It is the same as what we have up here. Since the x minus 5 is in the bottom, it really is being divided by that. But it just better matches up to some of the other problems we've done. All right, now if this thing is going to simplify, it'd be really nice if one of these had an x minus 5 as well. Fortunately, there is a way where we can multiply something by 5 and get 40. That'd be when we have 5 times 8. So that's my guess of how this might factor, is maybe this is an x and an 8 and an x and a 5. The larger one has to be positive since I have a positive 3 in there. So sure enough, I do have a factor of an x minus 5 I can go ahead and cancel out. All right, let's go ahead and do that. Cancel, cancel. This will leave us with an x plus 8, all divided by an x minus 1. All right, and now all of these are simplified.
31, we're trying to add or subtract these expressions here. And the key is when you add these rational expressions is you want to have a common denominator. And so here you can see, like, I've got c squared, like 2 c's multiplied together. Here I have just 1 c. So what you can do is you can look at what you're missing. So like here I need 2c, so I need to multiply this by c. Whatever I do to the denominator, I have to do to the numerator, because c divided by c is like 1. When you multiply by 1, you're not changing the value of that fraction. But then this one, I'm missing a 3, so I'm going to multiply this by 3 and the top by 3. So now you can see we have 15 over 3c squared. Here we have 2c over 3c squared. Now we have a common denominator. We can combine this into one fraction with the common denominator, and it's just going to be 15 minus 2c. Now you want to try to combine it as much as you can. You also want to see if you can do any factoring, because sometimes you can get some cancellation that occurs in the numerator and denominator, but that's as far as we can go on that one. For letter B, if you look at the two denominators, x plus 1 is like a group, x minus 1 is a group. There's really nothing in common. Sometimes students mistakenly think of this as 1 times x or negative 1 times x, but this is like a binomial. So there's really nothing in common between these two denominators. So what I'm going to do is I'm going to multiply what I'm missing. I'm missing an x minus 1 in this denominator. So whatever I do to the bottom, I have to do to the top. Here I'm missing an x plus 1, right? So whatever I do to the denominator, I have to do to the numerator. So now our common denominator is x minus 1 times x plus 1. This is going to be 2x minus 2. This is going to be, I'm going to treat this like a negative 3. So that's going to be a negative 3x minus 3. And now if we just combine like terms, we get 2x minus 3x, which is negative 1x, negative 2 minus 3, which is negative 5, all over x minus 1, x plus 1. Now you could multiply this out or leave it factored. Usually teachers just have you leave it factored like that. For letter C now, what I want to do with this one is I want to factor the denominators as much as I can, because I want to see if there's anything that's in common. So here if I factor this, I get x minus 5 and x plus 4. So now when I look at these denominators, I say, well, I already have an x minus 5 in common. This has an x plus 4. We need an x plus 4 over here. So I'm going to multiply by an x plus 4 to the denominator and the numerator. So now our common denominator is x minus 5, x plus 4. Okay, here I'm going to distribute the 3x, so that gives us 3x squared plus 12x plus 7. And then what you can do is you can see if you can factor this further. Is there anything that multiplies to 21 but adds to 12? No. So this one's not factorable. That's as far as we can go, and you got it.
In this set of problems, we want to work on solving some rational expressions. There's a few different ways you can handle the solving process, but one of my favorite is to find a common denominator and then multiply through by it to really clear out all of the denominators. That way you're not really worried about fractions the entire time. So for example, I might look at each of their denominators and say it has a common denominator of a 30x. And then I can use that and multiply it on both sides. So what I'm saying is I can take 30x, multiply it by 2 over x, and then take a 30x, multiply it by an x minus 4, all divided by 30. Now watch what happens when you do that and why it's such a nice process. These x's are going to cancel, and these 30s are going to cancel. So the equation that I'm really left with in the end is really just 30 times 2, which is the same as 60. Over here on the right side, I have an x and an x minus 4. So a much simpler problem than what I started with. Now it's just a nice problem with no fractions, and I can move to solve for x. So let's go ahead and distribute that x in there. So that'd be 60 is equal to an x squared minus 4x. Ooh, looks like we can see that it's a quadratic. So we can solve it by getting a 0 on one side, and then doing some factoring. Let's see, what does this factor into? I'll have 0 is equal to, get some parentheses in here. Let's see, two numbers that multiply to give me 60. How about 6 and 10? That'll work. Where the larger one better be the 10, since they have to combine to a negative 4. So this will give us two different factors. Each of these could be equal to 0. X plus 6 equals to 0, or x minus 10. This will give us two different solutions. Either x could equal a negative 6, or x could equal a positive 10. Now with these, you want to make sure that it doesn't cause any problems in the original. Notice how in our original we're dividing by an x, so we want to make sure that any of our solutions that we do get, that none of them are actually 0, because we don't want to accidentally divide by 0. Since none of them are 0, we'll go ahead and keep both of them. And there's our solution for the first one. All right, so let's see what we can do with the next one. I like that idea of a common denominator. It really clears things up quite a bit. So let's see, what's a good common denominator for the next one? Well, I think 18 would be a great common denominator. 3 goes into 18, 6 goes into 18, and so does 9. So if I take everything and I multiply by 18, then we don't have to worry about fractions whatsoever. So we'll multiply that by 18. We'll multiply the x divided by 6 by 18. And of course, we'll multiply the 1/9 by 18. Let's see what this gives us. So the 3 goes into 18 6 times. And 6 goes into 18 3 times. And 9 goes into 18 twice. So what am I really left here? This is 6 times 2, which is 12, minus 3 times x equals, and 2 times 1 is just 2. So this is our new equation, no fractions to worry about. I like it. And now we work on getting x all by itself. So let's see. I can move the 3x to the other side. That way at least it's a positive number. Move the 2. And let's see, that's looking pretty good. And I guess our last step in all of this would be to just divide by 3. Now looking back at the original, we want to make sure that we never divide by 0. All the denominators here are a number already, that none of them are 0. So we can go ahead and just take this as a solution. All right, that looks good. On to the last one here. Here it looks like our denominators are pretty complicated, except for this last one here. You'll notice is an x plus 4 and an x minus 4, which is the same pieces as we have earlier. So I can use this as my common denominator, an x plus 4 and an x minus 4. X plus 4, x minus 4. So we're going to multiply that on the entire right side. And we're going to multiply it on the entire left side. It's kind of long, but that's okay. It's going to simplify nicely. All right, so as this term distributes to our left side, this entire thing has to go and hit the first fraction and the second fraction. Let's see what we get. The x plus 4s will cancel each other out, so we'll only be left with a 3, x minus 4. As it hits the second fraction, the x minus 4s will cancel out, so we'll only be left with an x plus 4. Over on the right-hand side, this is the same as the denominator, so both those will cancel out, and we'll just be left with a solid 4. So actually, that clears out things quite a bit. All right, on to simplifying it further. We can distribute a 3 into this first parentheses, so 3x minus 12. And then really work on getting the x's all by themselves. Let's see, if we combine them together, 3x plus x would be a 4x. Negative 12 plus a 4 would be a negative 8. Almost. Let's get that negative 8 to the other side. By adding 8, that would give us a 12. And then if I divide by 4, I end up with x is equal to 3. All right, so looking back at the original, we do not want a 0 in any of our denominators, so x cannot equal a negative 4, and x cannot equal a positive 4. Same thing here, can't equal a negative 4, can't equal a positive 4. My answer is none of those, so we'll take it as our solution, that x is equal to 3.
Okay, number 33, it's asking us to divide these two polynomials. So I'm going to show you two different methods. One is the long division, polynomial long division. The other is the synthetic division. So what we're going to do here is we have 5x squared plus 14x plus 2. This whole thing is being divided by x plus 3. So what you want to do is you want to see how many times does x go into 5x squared. So it goes in 5x times. When I take the 5x, I'm going to distribute it to both of these terms. So that's going to give us 5x squared plus 15x. Now when you subtract, what you can do is you can change the signs to the opposite and add. So that's a little bit easier way. You get negative x plus 2. How many times is x going to negative x? Negative 1 times. When we distribute that negative 1 to both of these terms, we get negative x minus 3. And then when you subtract, you can change the signs to the opposite and add, because subtraction is like adding the opposite. Now see how the 5 is degree 0, and it's lower than this degree, which is the first degree? This is your remainder, and what you would do is you'd put your remainder over your divisor. And that's it, and you've got it. Now the other method of doing this is the synthetic division. Now when you're dividing by a linear factor, meaning like x to the first plus something or minus something, you're going to want to put the opposite sign. So if you're dividing by x plus 3, what you're going to want to do is put negative 3 here. If you're dividing by x minus 3, you'd want to put positive 3 here. Then you just use the coefficients 5, 14, and 2. Okay, and what you want to do is you want to make sure you're not skipping over any terms. If you go from x squared to a constant, you'd want to put a 0 here as a placeholder. So then what you do is you drop down that first term, you multiply in the diagonal, and you add straight down. You multiply in the diagonal, and you add straight down. And when you're doing the synthetic division, we start off with x squared. It goes down by 1 degree, so this would be x to the first minus 1 plus the remainder, that's the last number's remainder, over what you're dividing by. And you can see you're getting the exact same answer. It's just that this is a little bit quicker if you're dividing by a linear factor. If it was like a x squared or something like that, then I would just do the polynomial long division.
Right, in this problem, we want to find the midpoint and the distance between the following 2 points. For the midpoint, a good way of thinking of this is that I'm taking the average of the x's and the average of the y's. So we'll do 3 plus 0 divided by 2. There's my average for the x's. Negative 4 plus a negative 8 divided by 2. And this will form a brand new point. This will form the midpoint. All right, 3 plus 0 is just equal to 3. And we divide that by 2, we'll get 3 halves. Negative 4 plus a negative 8, or negative 4 minus 8, is a negative 12 divided by 2 still. So that's getting a little bit simpler. And we can simplify that second fraction, so we'll go ahead and write this as 3 halves and a negative 6. So there's our midpoint. For the distance between these two, you might think of the formula where the distance is equal to the square roots, and then we can take the difference of the x's squared and the difference of the y's squared. Just to keep things in the same order, not that it really matters too much, you can consider one of these points as point number 1 and point number 2. That way you know where I'm grabbing these various x's and y's. All right, so let's give it a shot. We'll take the second x value, 0, minus the first x value, 3. We'll take their difference and we'll square it. For the y's, we'll take the second y value, negative 8, and subtract the first y value, a negative 4. We'll square that. And then we'll take the square root. So let's see, on the inside here, I'm taking a negative 3 squared, so there's a 9. Negative 8 minus a minus 4 is the same as negative 8 plus 4, so negative 8 plus 4. And that's the same as negative 4. And then all of that is being squared. So negative 4 squared, 16. Of course, this is all still under a square root. So now I'm looking at 9 plus 16. Or I'm looking at the square root of 25. All right, that's looking pretty good. The square root of 25 is just 5. So the square root of 25 is just 5, and that gives us our distance. All right, so now we know the distance and the midpoint between these two particular points. Thank you so much for watching. If you want to see more videos, you can visit either one of our websites, either MySecretMathTutor.com or Mario's Math Tutoring.